Welcome to Star Chat, the cosmic journey that takes you to the farthest reaches of our universe and beyond. I'm your host, Carl, and we're thrilled to have you join us today as we embark on a fascinating adventure through space and time. As we gaze up at the night sky, we're reminded of the infinite possibilities that lie before us. The stars, like diamonds against the velvet blackness, whisper secrets of the cosmos, and humanity's innate curiosity drives us to explore, to discover, and to push the boundaries of what's thought possible. And speaking of exploration, today's top story is a thrilling one. NASA has unveiled its plans for a permanent base on the Moon. Yes, you heard that right. A lunar base where humans will not only set foot but also establish a sustainable presence, marking a major milestone in space travel and research. Imagine it, a bustling hub of activity at the Moon's south pole, with astronauts living and working together to unravel the mysteries of our closest celestial neighbor. The implications are staggering. From advancing our understanding of the lunar regolith to harnessing the Moon's resources for future missions to Mars and beyond. According to NASA's phase plan, the first mission is set to launch later this year, with at least 25 robotic exploration and experimentation missions scheduled over the next 3 years. These will lay the technological and symbolic foundations for the lunar base, which will be built in 3 phases: robotic exploration, semi-permanent infrastructure assembly, and finally, scale up to a durable, self-sustaining center. As NASA Administrator Jared Isaacman so eloquently put it, every mission, crewed and uncrewed, will be a learning opportunity as we return to the lunar surface, build the infrastructure to stay, and master the skills required to live and operate in one of the most demanding and dangerous environments imaginable. The Moon, once a distant dream, is now within our grasp. And as we take this giant leap for humanity, we're reminded that the universe is full of mysteries waiting to be unraveled, and the next great chapter in space exploration is being written right before our eyes. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue to explore the vast expanse of space and its many mysteries, we find ourselves pondering some rather intimate questions. Can humans reproduce in space? It's a query that has sparked the interest of scientists and space agencies around the world, including China, which is currently conducting an experiment on its space station to study the effects of microgravity on human embryo development. Imagine being 250 miles above the Earth, floating in a low-gravity environment where the rules of physics as we know them are slightly bent. It's a challenging setting for many everyday activities, from sleeping to using the bathroom. But what about something as fundamental as creating life? China's experiment aims to shed light on this very question by studying embryo-like structures made from human stem cells in space. These artificial embryos, which don't have the ability to develop beyond the embryo stage, will spend 5 days in low Earth orbit, a critical period during which most organs begin to form. Scientists are eager to see how microgravity affects their development and whether it increases the risk of birth defects. This research is crucial as humanity prepares for long-term space habitation and potential colonization of other planets. But, as fascinating as this study is, it also raises some intriguing and somewhat awkward questions about sex in space. As it turns out, Newton's third law of motion could make intimate activities a bit more complicated than they are on Earth. The lack of gravity would require some creative solutions to, shall we say, keep things together. And then there's the issue of blood pooling in the head and sweat clinging to the skin, not exactly the most romantic conditions. Even if conception were possible in space, there are many unanswered questions about how a baby would develop in a microgravity environment. Would they form bones normally? Could they adapt to life on Earth upon return? These are just a few of the puzzles that scientists like Dr. Chris Lenhart have been grappling with. China's experiment is an important step towards understanding human reproduction in space, but it's clear that there's still much to be discovered. As we push the boundaries of space exploration and consider establishing human settlements on other planets, these questions will become increasingly relevant. For now, the study of artificial embryos in space offers a glimpse into the complex and fascinating world of human biology beyond our planet. Welcome back to Star Chat. As we conclude today's show, let's dive into a fascinating topic that has sparked debate and curiosity among astronomers and space enthusiasts alike: the possibility of interstellar travel. A recent article caught my attention, exploring the feasibility of extraterrestrial life visiting our planet. The author presents a compelling argument, highlighting the numerous engineering challenges that come with traveling through space at incredible speeds. Imagine a spacecraft hurtling through the cosmos at 19,000 miles per second, roughly 1/10 the speed of light. To achieve such velocities, our hypothetical alien friends would require an enormous amount of energy, which could be generated using various propulsion methods, including chemical, antimatter, or nuclear fusion. However, each of these options comes with its own set of limitations and obstacles. For instance, chemical propulsion, which has been used in all human space missions so far, is woefully inefficient, requiring an absurd amount of fuel to reach the desired speed. Antimatter propulsion, on the other hand, offers a much more efficient solution, but is extremely difficult to produce and stabilize. Nuclear fusion, while promising, still faces significant technological hurdles. Moreover, as our alien spacecraft travels through interstellar space, it would encounter a plethora of hazards, including cosmic dust and radiation. The ship's structure would need to be designed to withstand these threats, which would add to its overall mass and, in turn, increase the energy required for propulsion. The article concludes that while there's no single law of physics prohibiting interstellar travel, the cumulative effect of these engineering challenges might render it physically infeasible. However, it's also possible that advanced civilizations have discovered innovative solutions to overcome these obstacles. As we ponder the possibility of extraterrestrial life visiting our planet, we're reminded of the countless mysteries waiting to be unraveled in the universe. If an alien spacecraft were to arrive on Earth, it would raise a multitude of questions. Where did they come from? What's their purpose? How did they overcome the seemingly insurmountable challenges of interstellar travel? The search for answers to these questions drives us to continue exploring, innovating, and pushing the boundaries of human knowledge. As we gaze up at the stars, we're reminded of the infinite possibilities that lie beyond our planet. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.